Hey there everyone, welcome back to my YouTube channel. So guys, this is video 9 of our machine learning playlist, and in this particular video we will be discussing about different encoding techniques in machine learning. So guys, there are various encoding techniques. In some of them are one hot encoding, label encoding and ordinal encoding. So we will be discussing about this particular main important encoding techniques in detail in this particular video with practical implementation. So guys, why are you all waiting for? Those who all have not subscribed the channel, do subscribe the channel and on the bell notification for more videos, and also make sure to connect with me on LinkedIn. My LinkedIn URL will be in this video description, so feel free to connect with me and message me if you have any queries. So now let's not waste our time, let's dive into my computer screen and discuss more about this particular topic. So guys, you can see here, this is the article for this particular video. If you are following my machine learning playlist from starting, you all might have already noticed for each and every video there will be definitely one article, so that you all don't need to note down anything. If you just follow these articles, it will be enough and you all can read everything in detail. So I don't want you all to make any notes right now, just understand whatever I am explaining, and practical implementations also will be there. You can execute with me parallelly when I am implementing practically. So now let's go further. Firstly, what is data encoding? Encoding refers to the conversion of categorical or text data into numerical format that is easy and understood by the machine learning algorithm. So let me just tell you all an example. Normally, see, whatever we are writing or else we are giving input, right? It will be in our normal human language that one machine cannot understand. So if the machine should understand, it should be in binary language. So what we will be doing? We will be doing encoding, which is nothing but zeros and ones. We will be converting whatever data is there, right? When we have, if it comes to the machine learning use case, we will be having so much of data. Once we have performed standardization and normalization, and once the data is perfect, so those who all don't know about standardization and normalization, you can check out my previous videos. It is about that particular topic. After that, what we'll be doing, we'll be encoding that particular data. So whatever is in English language, we'll be encoding that into numbers so that our machine learning model can train properly and it can run smoothly. So for that, we will be just converting into numbers. So about that we will be discussing. There are mainly two different types of textual data. One is nominal data and ordinal categorical data. Nominal categorical data is, in a sense, like there will be no order. The labels will be there, but there will be no order or ranking. It will be like however it want, it will be there. Like for example, like gender, like you can think of a classification data, like two or more, that's all. When it comes to ordinal categorical data, it represents the meaningful order of ranking. Like you can take a loan ID as an example, like ID of a person or marks of a student or price. These all are like ordinal categorical data. Means continuous data is there. But when it comes to this nominal categorical data, they are like types. Either you will get a loan or not, yes or no. Like when it comes to even hotel rating also, if it is 1, not good. If it is 3, medium level. And if it is 5, then that hotel is excellent. So it's a kind of classification. So that is nominal categorical data. So we have seen these types of categorical data. So now what will be like? So there is an example right now here. Let me read out this example for you all. I already told you all an example right now of hotels, but let me read this example for you. Imagine you are building a recommendation system for an online food delivery website. Okay. So like you can think of a restaurant. Okay. So for that, what you have to do? So as I told you all, see, the rating will be from the scale of 1 to 5. So here what it is there: poor, fair, good, very good and excellent. So if the rating is 1 of that particular person, so in the data, if wherever there is 1 in rating, that means that the person is not satisfied with that particular restaurant. And if it is fair, that means rating is 2. And if it is good, okay, he has given the rating 3, in a sense, okay, it is a kind of good, but I am not more likely to this particular hotel. Okay, whatever maintenance and everything is there, good. When it comes to 4 and 5, that means that okay, rating is good and even I can refer someone for this particular hotel. So that is called recommendation system, right? a kind of recommendation we can provide. So from based on this particular ratings of a particular hotel, we can decide previous person's rating. So where there is more rating related to this one of that particular hotel, that means that hotel is not providing proper services, so we don't need to go there. So we will get a proper recommendation which best hotels we have to go. I hope you are getting this. So that's all about this. So I wanted to give you this example. It's done. Just read out this. We have written this very beautifully. Just read out. You will understand a bit more better. So different encoding techniques. There is one hot encoding, ordinal encoding, and label encoding. So let us discuss about all these particular encodings now. One hot encoding. This technique we use to apply on nominal categorical data. One hot encoding converts categorical data into a binary matrix where each category is represented in the unique binary of 0 to 1 scale. So like if you see this particular image, right? See, this is the particular image. Here you can see like there are so many features. So we have done one hot encoding. So New York. So if it is New York, 1. Then left all other things are 0. If it is Boston, 1. So this first one, whether it's New York, no. So it's 0. So Boston, it's Boston, 0, 0. So it's nothing but we are just selecting, like we are just creating a separate column for each and every row features. You can say like this. So one hot encoding. So for this, even we have an example here. Let me explain with an example, and even there are some drawbacks also. You can see the code here. First, let me explain this with an example, and I'll tell you what are the drawbacks with one hot encoding you might face normally. So let me just connect to my collab notebook. So this is one hot encoding. You can see here the technique used to apply for nominal categorical data. Okay. We can see here from the scale of 0 1. So we'll take an example of Irish dataset. Okay. So we'll be working with Irish dataset for understanding easily. Don't worry, for everything we have written in hashtags here also for your better understanding. First, let us import the required libraries. So yeah, you can see here import pandas as PD, numpy as NP. So matplotlib and seaborn we have imported this. So now next data. So from sns.load dataset. So in SNS there is an inbuilt dataset called Irish. Even there are many other datasets in SNS also, and even sklearn.datasets. In that also there are many datasets like wine quality prediction. Many datasets are there. House price prediction also is there. You can have a look on all those datasets. So I am loading that, and if you see the original dataset head, so this is the original data set. So from the above data, you can see the categorical data, which is nothing but this species. So now what we have done here, pd.getDummies is one hot encoding of specific using pandas. So we have used pandas here, and let me run this pd.getDummies. Now what it has done, species.setosa, species.versicolor, species.verinca. So all these particular things what it has done. So from this you can see here this particular species. For example, let me show you this here clearly. So it's df, right? Irish.head, okay. So pd.getDummies. So if you check the values underscore counts, right? I have showed you all previously also for this particular species, original data set. So Irish, right? Okay. IRIS. So Irish. So Iris of its species, right? Let me copy this species. Paste it here. Dot underscore count run. Okay, value underscore count. Let me just take values only. So you can see here in values you can see here setosa. So it's a kind of array. So you can take like this. So setosa, versicle, and this one. So there are only three features if you see here. Only these three features are there. You can actually use values underscore counts and get only these three feature names. Just have a look on that. You will get in detail. So normally only these three things are there. So we are going to encode only these three things. So here those three things only are columns, or else you can say those three rows only have been created into separate columns for getting encoded. We have used get dummies for this, and it has created that. Now one hot encoding. K1 one hot encoding method. This method is also a pandas dummy method, but here we will drop first unique characters of each categorical column using drop first is equals to true. To use this technique, what we will be doing, pd.getDummies and drop first unique is equals to true. So here what it happens, so you can see here versicolor and this one is there, but you can see setosa has been dropped here. So there are three are there, right? So from this the first one will be unique, one will be automatically dropped. So you can observe here, this is another method to use it. So when you drop the first one, then you can even your features will be a bit less and you can perform soon. Okay, one hot encoding using sklearn. So from sklearn, we will be using one hot encoding method. Normally, so if you see this get dummies and this get dummies first is equals to true drop method, right? That we'll be using very rarely when we are learning. But when it comes to the huge data set, right? When you have your own data set to be performed and it's a huge data set and you don't want to lose the features, then you will be definitely using the encoding one hot encoding method, which is in sklearn only. So from sklearn.preprocessing import one hot encoding. So one hot encoding we have imported here. So here also we can use drop first here also, but I don't want to use that because sometimes dropping the first one is not going to help us because there will be some important features. We don't want to lose them. So one hot encoded is equals to pd.dataframe ohe.fit. So we have taken one hot encoding here, right? We have renamed one hot encoding to ohe. So it's not an issue. From that we have taken the species, and then what we have done, we have again encoded this particular species. Now you can see here after running, so setosa is coming at first, right? So you can see all the setosa here, and versicle and everything will be there in this particular column. So this is the different methods to do one hot encoding. Okay, you can either use this or that, but both are same. But normally when it comes to the real-time scenario, you will be using more of this one hot encoding using your sklearn. So make sure when you are learning about one hot encoding, just learn well about this, how to use from sklearn, and explore the different techniques, like how can you perform the encoding. And one more main drawback you will be getting here is you will be getting a more of dimensionality problem. So now you can see here, until species it was okay, but when there are only three features, so you're not seeing. So this particular three features, it has created a three columns. So if there are somewhere of 10 features, 20 features, new features, then what you will be doing? If you use one hot encoding, it will create 20 new columns, which creates dimensionality problem, and it leads to the performance issues in your particular model. Training will become very slow because of so many columns, so much of training. So that time we have to use some other techniques. There are many other techniques like feature hashing and many other encoding techniques are there. You have to use them. When it comes to one hot encoding, the main drawbacks is it cannot handle the dimensions properly. You will mainly get dimensionality reduction problem here. So that's done. You can see the collab notebook is available here for you all. You can just open that, run and see, and if you want you can make the changes also of your choice. Okay, you can take that codes from there. Now let's move to ordinal encoding. It's another technique used in machine learning to represent categorical variables. So ordinal encoding is mainly used for categorical variables. Unlike one hot encoding, which creates binary vectors of each category, ordinal encoding assigns a unique numerical value for those particular category based on the order and importance. So normally what one hot encoding does, if you see in one hot encoding here, it creates a vector columns. Okay, but when you see here in this particular ordinal encoding, it will just create one column. But if you see a poor 1, good 2, so it just assigns a unique value for each and every feature. It makes sure that there will not be more dimensionality reduction problem in ordinal encoding. So the imagine example of customer rating. So you can see here, I have already told you, right, about customer rating. You can see here, by seeing this you will get it. Poor, good, very good, and excellent, and 1 2 3 4. So you can see this how it is going on. Okay. Normally this brief overview is enough for you all. You don't need to understand more detail about this. In one hot encoding you don't see much also. Don't worry. So you can see here I have opened the collab notebook out here. One hot encoding technique. So for this what we'll be using, we'll be using a dataset called tips. So that is also available in your particular datasets only. From SNS only it is available. Import pandas as PD pandas, Seaborn and sklearn. Import all the necessary things. And then finally run this one called as tips. sns.load data tips. df is equals to head, df.head, df.columns you can see here. Total bills, tips, smoke, sex, day, time, size. So these all are there. So from this where we can use ordinal encoding. So apply ordinal encoding for day. So you can see a day. So unique days in a day column is Saturday, Sunday, Thursday and Friday. So these categorical are nothing but objects of 4. So when we create categories it will become 4 objects. So where it happens like Sunday will be having 1, Saturday will be having 2, and Thursday will be having 3, and Friday will be having 4 objects. I'm just telling of an example. The numerical assigning it depends on that particular column. So let's run this. Without any specific order, directly applying ordinal encoding on days column. So without any specific column, if you run, you will see here it has created for Saturday 1, and for Friday it has taken 0, Thursday it has taken 3, and Sunday it has taken 2. So you can see here there is no proper specific order. Because of that it randomly took. So there is no proper data. There is no proper assigning for those particular values without specifying. So now what we'll do, let us specify. So days order is equal to Thursday, Friday, Saturday, Sunday. So this is my order. So from Thursday it should start. So then what happens? So once we run this particular code, and once we create the object, now if we like impute that and run, right? So now you can see Thursday got 0, so Friday is 1, and Saturday 2, Sunday 3. So it has given in a specific order. So even the order matters to particular data. Okay, make sure that ordinal encoding represents that only. Ordinal encoding means that you should have a proper order, or else it cannot work properly. Okay, so that's all. So choosing the right encoding also matters when you are performing the things. Okay, so let us see about this one also, label encoding, and the drawback when it comes to ordinal encoding, right? If the data features are not in order, and if you don't give order properly, right, then the ordinal encoding is not good and it doesn't perform well. So there is a chance of drop down of the accuracy, and even the model performance will be worst. Label encoding. When it comes to label encoding is a technique used in machine learning to convert categorical data into numerical format. So why we mainly use label encoding? So when we have a categorical data and we want to convert it to numerical data, like for example, A, B, C. So team A, B, C, these all are the categories, right? Whatever in English, you want to convert them to numerics. So then we will be using them. So for that what we will be doing, you can see here, first let me show you this image and explain. So team A, B, C. So A is 0, B is 1 and C is 2. So it has taken this particular label encoding. So, and one more thing, let me tell you all guys, important thing to be mentioned. Label encoding is only recommended to apply on the target variable. Means, see, now in your machine learning, you know, right, you will be having X and Y data. X is your like training data, or else the main data. Y is your prediction data, or which one you want to get predictions from. So if you perform predictions, like if you directly perform on the training data, this label encoding, it will not perform well. Whatever target variable you have, for that you have to perform Y variable, or else for that you have to use label encoding. Let me just show this example and explain you better. I guess that's already here only in this particular one only. So label encoding, you can see here. We will consider the same data set. df.head, if you see here, we can consider that particular same data set. So, and let us get unique from this. No, yes, categorical data, two objects are there, yes and no. Female, so for this also it is same. So what we will be doing? So these two objects are there, right? So yes is 0, no is 1. Male is 0, female 1. So we can assign like this, lunch and dinner. So these three topics we'll be taking. Since it's a binary data, right? So we can apply on this particular data set, whatever it is there. So if you run for smoked and when you encode this and if you run right, whether he has smoked or not, you can see here, yes means 1. So he has done smoking. No means no, he has not done smoking. So 0. Label encoding for this particular target column sex also. And for that also female or male. Female is 0, male is 1. Same for label encoding also. Lunch is 1 and dinner is 0 for this particular time, for this time encoded. And finally, the data frame will be included of all these things. So when you see all this, you can see here days encoded with order. Okay, these all are ordinal encoding, but we are talking about label encoding, right? These three are of label encoding. These three columns are for label encoding, and these two are for ordinal encoding, order encoding. Okay, remember this. And once you got this one, you can drop down this. See, for suppose in this particular data, your target variable is only to predict based on that particular tips, right? Your target is only to predict a person based on this input data to say that he is doing smoking. Then your target variable is only smoking. So you have to only apply your label encoding only on smoking, whether he is smoking or not. So when you give the input variables, it should say based on that he will smoke or he will not smoke. That's all. Nothing more than this. Don't worry guys, just try to understand the concepts, okay? And in our upcoming videos, we'll definitely do a bit more detail and we'll be doing the projects in detail for this topics for better understanding. This one is only the examples to explain you all. Try to use and run them, you will get it. And you have the sklearn's documentation here. So you can see here in sklearn also it has written transformation should be applied only on y data and not on the input x data. So try with different features like methods are there, parameters are there. Just try with them and explore these particular parameters like self dot output what it does, inverse transform what this will do, get params what this will do, transform y, all these things, right? Whatever it is that try to perform different things, you will get more detailedly about this particular label encoding, ordinal encoding and one hot encoding. And I recommend you all try to read the documentation properly of each topic. The documentation will have good examples and good parameters and everything. Okay, so guys, that's all for this particular video. We'll be continuing in our next video. Those who have not subscribed the channel, do subscribe and connect with me on LinkedIn. Thank you all. Bye bye.